This is the basic form for trigonometric functions with an altitude A and sine. It could be sine, cosine, tangent, cotangent, could be any of the 6 trig functions. B represents the period, so if there is a period in front of the, a B value in front of the theta, that helps figure out the period using the whatever formula you need, whether it's 180 divided by B for tangent and cotangent or 360 divided by B for the rest of the functions. Theta minus H. H represents the phase shift, which remember is the horizontal shift. And it is also feels backwards, so minus goes to the right and plus goes to the left. And then outside of the grouping symbols will be plus K that represents the vertical shift. So any number in the K position moves the entire graph up or down. So to graph a transformation, state the amplitude, period, phase shift, and vertical shift for that function, and then graph the function. So we'll just take each piece one at a time. We'll start with the amplitude. So the amplitude is the A value, which is right there. So the amplitude is 3. The period, we use normally we use 360 divided by B to find the period, but notice this one is in terms of pi. So since it is in terms of pi, we're not going to use 360 divided by B. We'll use the radian equivalent of 360 in terms of pi, which is 2 pi. So the period is going to be 2 pi divided by the B value. The B value is 2/3, so that would give us a period of 3 pi. The phase shift, so again, that is my horizontal shift, is going to be pi units right. And then the vertical shift, that'll be the number that is not grouped. That's at +4, so that represents 4 units up. So that's all the questions that asks us, and then it says to graph the function. So to graph this function, I'm going to go ahead and graph the parent function, which is y equals 3 sine 2/3 theta. So basically the parent function is going to be everything except for the parts that are involved in the shift. So ignore those parts when you graph the first part. So y equals 3 sine 2/3 theta. It is going to have the same amplitude and period as the final graph. So since it is a sine function, we will start at 0. With a period of 3 pi, it will end at 3 pi, which is right there. It'll reach its highest point. It'll hit the midline again, halfway between those 2 points. That's actually right there. That's pi and a half. It'll hit its high point between those 2 points. Since the amplitude is 3, the highest point will be right here. That's 3 and halfway between 0 and 1.5 pi. And the low point will be halfway between the 2 intercepts on this side, which is right there. So this, just do a dotted line, represents 1 full period of the unshifted graph, but now we're going to shift that, so I'll do that in blue. And the shift is pi units to the right and 4 units up. Well, I'm going to draw the midline at 4 units up to help us graph this. So that is not an asymptote. That dotted line is not an asymptote. It is the midline. So this first point right here, we're going to go pi units right and 4 units up. So pi units right would be 2 blocks over. Since I have 4 blocks representing 2 pi, then 2 blocks would be 1 pi. So pi units right and then 4 units up. We'll place it right here, which it should be on the midline because that 0, 0 point was on the horizontal axis, and it's like we move the horizontal axis up 4 units up. And then I'll do the second point, which is the peak of the red graph. I'm going to move it pi units to the right, so that would be 2 squares to the right. And since it is 2 squares to the right, it will still be in the middle of a square, and then 4 units up. 1, 2, 3, 4. Places it right there. And then the middle point on the x-axis, move it pi units right, 4 units up. That'll place it on the midline. And we just keep doing that with each point. So the bottom is pi units right, 4 units up. And then finally, this last point, pi units right, 4 units up. So there is one full period of the shifted graph. And notice you can kind of follow that same pattern with those 5 points all the way through if you want to make the graph larger. So notice that on the scale that we chose, that it is going, each point is 1.5 units to the right or left, and then 3 units up. So I can continue this graph. So I could go 1.5 and up 3. That would be the next point. Then I would need to go 1.5 over and down 3. 1.5 over, down 3. Again, that's because of the scale that was chosen, 1.5 over, down 3. So here would be a second period of that graph. And we can just do that as far as we want. State the amplitude, period, phase shift, and vertical shift for this graph, and then graph its function. So again, starting with the amplitude is 2. The period, this one is also in terms of pi. So it will be 2 pi divided by, the b value is only 1/2, so 2 pi divided by 1/2 is 4 pi. The phase shift is pi over 2 to the left. Since it says plus pi over 2 in parentheses, it is pi over 2 to the left. And then the vertical shift is 2 units down. So we're going to graph the parent function, which is y equals 2 cosine 1/2 theta. Again, just negating everything that involves the shift. That's what we're graphing for the parent function. So 2 cosine 1/2 theta, and let it start at 2, 0, 2. And since we have a period of 4 pi, it ends at 4 pi, which is right there. The low point will be halfway between those at -2. And then it'll hit intercepts halfway between those points. So this gives us one full period of the cosine function without being shifted, but let's shift that now. The midline is going to get shifted down 2 units. So again, that is a midline. Each point will now be shifted pi over 2 to the left and 2 units down. So since I have gone every 4 blocks is 2 pi, means every 2 blocks is 1 pi, so 1 block is going to be equivalent to 1/2 pi. So we're going to move every one of those points 1/2 pi to the left and 2 units down. So that would be 1 block to the left and 2 units down, which will place the high point right there. This second point at the midline will now be moved 1 block over and 2 down, because 1 block, again, is 1/2 of a pi, and 2 units down is for the -2, and same for every point in the pattern. So the fourth point is 1/2 over, 2 down, back to the midline, and then the last point's 1/2 over and 2 down, places it right here. So here is one full cosine period. And notice that the pattern is continually, it's over 2, down 2, or up 2. So I can continue that pattern. Over 2, down 2, over 2, down 2, places it down at the low point. And then I start going over 2 and up 2, over 2 and up 2, places it back at a high point. So there is a second cycle in the pattern.